Okay, welcome back to our third day. And so we're going to continue on working on atomic theory. And today we're going to talk about electrons. So I'm going to go back and share my screen here. And again, we're going to start at our main Canvas page, go to atomic theory. And again, that brings us to our main atomic theory page. So far, first video identified physical and chemical characteristics of a substance. Our second video defined the characteristics of the three fundamental particles, protons, neutrons, and electrons. We calculated the mass of an atom and interpreted the mass and charge of isotopes. So we're just moving right along. Today, we are going to work on determining the charge of an ion. So day number 3, this is the one we're working on, electrons, charge, and redox reactions. All right, so again, there is a Google Doc that goes along with this for you to keep your notes. So let's get started with it. So electrons, as you might remember, are that small, elusive little particle that flits around outside the nucleus. And so let's talk about electrons. The atomic particle not located in the center of the atom is the electron. Protons and neutrons are inside the nucleus at the center of the atom. They are the ones that have mass. So the properties of electrons, their mass is, for all practical purposes, 0. So you can write 0. Their charge is -1. And when I know in math class, when you say those numbers like -1 or 1, you don't always put the word positive in front of numbers that are greater than 0. But in chemistry, when we refer to charges, we amplify that positive or negative sense. And so we actually say -1 or +2. All right, location of electrons is outside the nucleus. We'll get into precise locations maybe another time. All right, number 3, ions. Another new word here, an ion, the hardcore definition is ions are charged particles. They are a particle with a charge. So that charge, number 4, could be calculated by protons. Okay, those are the ones with the positive charge, minus number of electrons, those are the ones that have the negative charge. So if lithium has 3 protons, that would be +3. And if it had only 2 electrons, that would be 3 minus 2 for a charge of +1, okay? If oxygen had 8 protons and 10 electrons, then it would be 8 minus 10, or a charge of -2. Both those examples are ions because they have a charge, +1 or -2, okay? Another example, if we had neon that has 10 protons and 10 electrons, 10 minus 10 is 0, there is no charge, it is not an ion. Ions must have charges. By definition, they are a charged particle. All right, number 5, charges can be positive or negative. Positive or negative. They cannot be 0. No zeros. Positive or negative numbers work for us. All right, so let's do a little practice. Lithium with 4 electrons has a charge of, well, we got to go look here, because lithium has 3 protons. And so in my example, if it has 3 protons and 4 electrons, well, 3 minus 4 would be -1. Boron, well, we got to go over here and check where boron is. Boron right there, 5 protons. How do I know that? Because that's the atomic number. So 5 protons. Okay, so 5 protons minus 5 electrons, that's 0, 5 minus 5. So charge of 0, it is not an ion, okay, because it has no charge. Carbon, got to go find carbon over here. So carbon's right up here. It has 6 protons. So that is a charge of, let's see, 6 minus 3 electrons. So 6 minus 3 is +3 is the charge. So it is an ion, has a positive charge. Lithium, well, we just looked that one up. It had 3 protons. It has a charge of +2. Well, let's see. 3 protons minus the number of electrons has to be +2. 3 minus 1 is 2. So it has 1 electron in that case. 3 minus 1 is 2. And boron, well, we know boron had 5 protons because we looked it up. So boron has 5 protons. So 5 minus some number of electrons is -2. So let's see, if I'm thinking about a number line, I've got to go from +5 all the way back to 0. So that's at least 5 electrons plus 2 more, 7 electrons. 5 minus 7 is -2. 5 minus 7 is -2, so 7 electrons. And some of you might ask, is there, they really can do that? There's that much variability? Yep, there is. And so why is there that much variability? There's really good reasons for it, and I'm going to get to that a little bit later in our unit when we're looking at the periodic table. All right, number 7. We're going to start into a new process as we start into question number 7. We're going to talk about a process called oxidation and reduction. We actually in class broke this Google Doc into 2 parts. This first part, questions 1 through 6 on the first day, and then the redox oxidation reduction reactions on the second day. So I'm going to do that here as well. Tune into the next video and catch up on oxidation reduction reactions.